Hello, everybody. Let's go ahead and take a look at day 3. So in day 2, we worked on some reflections, and those were just over the x-axis and y-axis. So we have a little bit of review for those. If we flip over the y-axis, then that means the y-coordinate is going to stay the same. The x-coordinate, though, would be negated, which just means change the sign. So if it was positive, it becomes negative. If it was negative, it would switch to a positive. Then when we reflect over the x-axis, the x stays the same, and we negate the y-coordinate. So the y-coordinate will just change signs. The line of reflection is the perpendicular bisector of a segment between corresponding points on the pre-image and the image. So if we drew an imaginary line connecting specific points from the pre-image to the image, then it would be a perpendicular bisector of the space between them. Reflections are rigid motions. Rigid motions are going to not change the size. The image and pre-image of a reflection are congruent because rigid motions preserve side length and angle measure. Rigid motions will keep the size the same, which makes the pre-image and image congruent, same size. In your own words, how do you perform a reflection? Well, I don't know your words, but something about counting the distance between the pre-image and line of reflection and going the same distance on the other side of that line. So now let's actually practice. We're going to start by reflecting over the line y equals x. Let's begin by plotting the triangles. So go ahead, plot triangle ABC and DEF on these graphs. I'm going to pause the video and go ahead and plot those points. All right, so now we have the pre-image plotted for both the top and the bottom question. Let's go ahead and get to the reflecting. Plot the triangles on the graphs, reflect the triangles over the line y equals x. So first we need to know what that looks like. Some people are able to picture it. If not, that's why we have this calculator. We can go to y equals x and then look at our graph. Second graph. Just kidding. Now we can look at our graph. Y equals x is the line where every coordinate, y and x, are equal. So it's going to go through 1, 1, 2, 2, 3, 3, 4, 4, negative 1, negative 1, negative 2, negative 2. So we'll take our ruler and connect the corners of the boxes. I'm going to do that in pencil. Make it dotted, you can make it solid, darker, lighter, whatever you want. But this is a line, and we know from earlier this year, lines have arrows. And just like you have a name, our line should have a name. This is the line y equals x. This is very similar to yesterday, but we're counting diagonally. We're counting the corners of the boxes instead of like the left and right or up and down. Let's start with A. Here's my line of reflection. I'm going to count the distance from my line of reflection to point A. Half a box and then a full box. 1.5. Now I'm going to follow that. So A to here is 1 and then a half. I'm going to keep going 1.5 corners in the other direction. Half and a 1. This is where A prime would be. And now we need to do that for the other points as well. So if we go to B, we're going to count the corners from B to this line of reflection. 1, 2.5. Keep going the same distance in the other direction. 1/2, 1 and a 2. Here's B prime. C to that line of reflection. Some people like to line up their ruler through the see that straight line. From C to the line of reflection, 1, 2, 3.5. So then we're going to keep going, 1/2, 1, 2, and 3. And there's C prime. This is going to be a new triangle, so we can go ahead and connect A prime, B prime, and C prime. Do 1 or 2 a little bit slower, and then we can pick up the pace. So the green was my pre-image, the red is my image. I know that from my apostrophes, my primes. So let's come over here. We've been talking about how these are the pre-image points. We put what happened to it above these arrows. So we're going to map by doing a reflection over y equals x. And over here, we can put the corresponding image points. So A prime is going to end at 2, 1, 2, 3, 4, 5, 2, 5. B prime ends at 4, -1. C prime, -3, 4. Some of you already might notice this pattern, but let's perform another one on the graph, just so that we can confirm the pattern. I already graphed the pre-image, well, half of it. Let's fix that triangle there. Now let's go ahead and put in that line of reflection. This one again is going to be where y equals x. It's a positive slope, so we're going to be going uphill from the bottom left, uphill through my graph. Name it y equals x. We're going to be doing the same thing, counting those diagonals. So from D to the line of reflection, I've got 1, 2, 3 corners. So I'm going to go 1, 2, 3 corners in the other direction. Here's D prime. It's nice when it's whole numbers like that, just won't always turn out that way. E, 1.5, 1/2 and a 1. Here's E prime. F, 1.5, 1/2 and a 1. Here's F prime. And if that kind of counting backwards, 1.5, 1/2 and a 1 doesn't work for you, then just go back and double check that they're the same distance from that line of reflection. Connect these 3 points to make our image triangle. Let's come over here. For our rule was that our transformation rule, reflect over y equals x. D prime started here, where did it end? Or -7. F prime. So now that we have 2 examples, we can do a generalization rule. It says look carefully at all of the 6 points, the pre-image and the image. Is there a pattern? This was -4, 2, ends at 2, -4. -7, -4, ends at -4, -7. So for this type of reflection, all that's happening is the coordinates are going to swap. They're going to trade places. So down here, describe what you see. The coordinates swap or trade or switch places. So a coordinate that starts at x, y, and then gets reflected over this line would end, flip those, at y. So our rule when we're filling out those tables, if I start at x, y, and reflect over the line y equals x, my coordinates are just going to swap places, flip-flop places. Y and x would trade. No sign changes, just a trade. Next page. So these pages are both really similar. This page is going to say reflect over y equals negative x at the top. Let's go ahead and plot the pre-image for both the top graph and the bottom graph. Plot A, B, C, D, E, and F in their triangles, and then we can regroup after we do that. Okay, so now we should have both pre-images plotted for the top and bottom. Now we can plot our line of reflection. This is y equals negative x, so not the same as the previous page, but you might be able to guess what this one would look like. I go to my y equals negative x graph. This is going to have a negative slope, start high and low from left to right. We're just going downhill through the corners of those boxes. Check right here, make sure it's in the corner. I go through the origin, that 0, 0. Can turn it a little there. And it's a line, so it needs arrows, and its name is y equals negative x. So we're going to count diagonally again. It's just that our line of reflection is tilted the other way this time. Let's start with B, just because it's at the top of the page. It's one of the closer points. B is 1.5 corners away. So then I need to go half into 1 corner away in the other direction. Here's B prime, 1.5, 1.5, same distance. Let's do C is super close here. Here's half of a box, here's half of a box, C prime. A is a little bit further, so just count slowly. 1, 2, 3.5. 1, 2, 3.5. I got carried away, so I had to double check. So I need 3.5 in the other direction. Half, 1, 2, and a 3. It's A prime. I know it's my image because there's primes. I'm going to go ahead and connect to make my new triangle. While there's a lot of little details, we can tell if we did something majorly wrong, because it would look a lot different. Like if point C prime was down here, then I know that something weird happened, because these triangles should be the same shape. They just moved. Let's go up here and talk about the transformation that we performed. We reflected over y equals negative x. When we did that, A prime ended at -2, -5. B prime ended at C prime ended -4. So there is a pattern that's happening. Let's kind of quickly go through the next one, just so we can get that practice in case they actually ask us to perform the reflection on the graph. Here's my pre-image done. I want to reflect this over y equals -x to figure out where D prime, E prime, and F prime would all go. I know what my line of reflection is going to look like because I just plotted it up above. Y equals -x is going to go through the slants and go downhill, go through the corners and go downhill. Give it a name. And now we're just counting those diagonals. F is half a corner below, so F prime is half a corner above. E, I pointed to D instead of E. Let's do D. D is 1 below. We're going to keep going. 1 above for D prime. E is further away, so count slowly. Half, 1, 2, 3, 4, and a 5. Here's our new triangle. Let's connect those points. Nothing looks majorly wrong, but when I go to count, I can make sure that I did plot it correctly because we should have a pattern going on. D prime, -2, 4. Seven for E prime, F prime, 2, -1. All right, so as we look through these, it does apply to all 6 points on the page, but let's just focus on the bottom here. -4, 2, -2, 4. Same digits, but some opposite signs, some place movement here. -7, -4, +4. Both signs changed, and the coordinates switched places. +1, -2, +2, -1. Both signs changed and the coordinates swapped places. So that's our pattern for this type of reflection. Both coordinates change signs and swap places or trade places. So anytime we have this reflection, both coordinates are going to trade places and change signs. So the front would become -y, negate it, change the sign. The back would become -x, negate it, change the sign. If we start with a coordinate and we reflect over y equals -x, they're going to trade places and both change signs. Let's keep it going here. Both the reflections over y equals x and y equals -x said, how does the line of reflection relate to a line segment joining the pre-image and image? The line of reflection is the perpendicular bisector of the segment formed It froze. Let's give it a second to catch up there. The line of reflection is the perpendicular bisector of the segment formed between the pre-image and image. Let's finish this page right now for practice, and then we can get you started on your homework. Triangle ABC has these coordinates for A, B, and C. State the coordinates of A prime, B prime, C prime after the following transformations. So this is really just practicing the rules. It's a lot quicker to know the rules. While you'll always have some graph paper, it might not always just be given to you in terms of like X's and Y's. So we should be able to apply those rules without always relying on the graph. If we reflect over y equals x, this is where the coordinates are just going to swap. They'll trade places. So let's write our pre-image, A, B, C, 5, 11, 2, 1, -3, 0. They're going to map to A prime, B prime, and C prime. Transformation is reflect over y equals x. All that's happening is they're swapping places. 511 would end at 11.5. 2,1 would end at 1,2. -3,0 would be at 0, negative. This is the one that takes a little bit more. This rule is easy, super quick, just swap them. Reflecting over y equals negative x is a little bit different. Let's write our pre-image. Start with the original points, 511, 2,1, -3,0. We're going to map them all to their corresponding image points. And to do that, we'll reflect over y equals negative x. So for both of these, they're each gonna trade places, switch signs. These would flip. Instead of 511, we would have 11 and 5, but they also both need to trade signs. -11 and -5. We're gonna swap the coordinates, so it becomes a 1, 2, but they both need different signs from what they had before. This would be a 0 and a -3, but they both need different signs than what they had before. 0 doesn't have a sign, so I don't need to change that. The -3 becomes a +3, and usually when we have a positive, we don't even write that, so I'm just going to go ahead and get rid of that. It would become 0, free. Coordinates of point P, the image of this point after a reflection over y equals x. Yes, we could graph it. We're going to try it without. Y equals x is when the coordinates just flip-flop. They just trade spots. So P starts at 3, -4. If I reflect it over y equals x, P prime, just trade places, -4, 3. And that's choice 4. Last one here, and then you can start your homework. Which reflection will map this quadrilateral, this four-sided shape, to H prime, L prime, P prime, Q prime? So I'm looking here. I could go ahead and label each coordinate. So write that L is at 0, 2, and it goes to L prime, which is at 2, 0. And I could analyze them like that. We also could just kind of look through our answer choices. The y-axis is this one right here. That means my picture would look the same on both sides of my ruler. It does not. Not that one. Y equals x would be this positive line. It's kind of hard to position it under the camera so you can see it. It's about right there. My shapes would look the same on both sides of this line of reflection. Looks pretty good to me. I think that's going to be my answer. When I have this reflection, the coordinates just swap places, and that's exactly what happened. There is another page of practice. You are welcome to do it. Come ask me about it. I will throw the answers up here quick. I don't expect you to do it, but if you are someone who wants some more practice, this is a great way to get that. That's going to end up in quadrant 4. And this is what this one would look like. Again, I don't expect you to complete this page, but it's extra practice if you want it. So go ahead and complete the day 3 homework over the next couple pages. Whoops, don't need to show you that. And I will check those next class. Have a good day.